How do we interpolate a mid-value in a dataset with regular X intervals? Learn the possibilities here in numerical solutions 2C problems. Given a dataset with 4 points, where the X interval is regular, the solution for interpolation is to complete Newton's difference table and interpolate based on the location of the point in the set. If X lies within the first half, solution should be with the Gregory-Newton forward interpolation. Otherwise, use Gregory-Newton backward interpolation. For both methods of interpolation, Newton's difference table is necessary. So with X and Y columns prepared, we take the delta Y starting with 7660 minus 7071, which is 589. Next is 8192 minus 7660, giving 532. Then 8660 minus 8192, resulting to 468. For the next level difference, we start with 532 minus 589, giving negative 57. The next is 468 minus 532, which is negative 64. Then the last column has negative 64 minus negative 57, which is negative 7. Having to interpolate a value which is exactly the midline of the data points, which should we use to solve it? The table in this case shows that we can either use Gregory-Newton forward or Gregory-Newton backward interpolation. Let's validate these two possibilities. With Gregory-Newton forward interpolation, we use the coefficients 15 for x0, 7071 for f of x0, 589 for delta y, negative 57 for delta squared y, and negative 7 for delta cubed y. With the pattern equation needing r, we solve it as required x minus reference x. That is 22.5 minus 15 all over 5. R is 1.5. Plug this value into the equation and start with f of 22.5 as 7071, plus the next term which is 1.5 times 589. 1.5 times 1.5 minus 1 by delta, which is negative 57, all over 2 factorial. 1.5 times 1.5 minus 1 times 1.5 minus 2 times negative 7 all over 3 factorial. These terms are simplified as 7071 plus 883.5 plus negative 21.375 plus 0.4375, which makes f of 22.5 as 7933.5625. Let's check if we get the same answer using Gregory-Newton backward interpolation. The coefficients for the next method are 30, 8660, 468, negative 64, and negative 7. R for the method is x minus x sub n over h. That is 22.5 minus 30 all over 5, which gives negative 1.5. F of 22.5 is then taken starting with 8660, plus the next term with negative 1.5 times 468, then followed by negative 1.5 times negative 1.5 plus 1 times negative 64 all over 2 factorial. The third term is negative 1.5 times negative 1.5 plus 1 times negative 1.5 plus 2 times negative 7 all over 3 factorial. The function is then simplified as 8,660 plus negative 702 plus negative 24 plus negative 0.4375. F of 22.5 is then 7,933.5625. The same value we got with Gregory-Newton forward interpolation.